There is a heating system, 3,000 years old. The Koreans built it. The Romans perfected it. The Chinese scaled it to 175 million people. 90% of South Korean homes still use it today. It requires no electricity, no moving parts, no monthly bill. In 1822, researchers tested a 400-year-old version at Malbork Castle in Poland. They lit a fire. 20 minutes later, an 850 square meter hall rose from 6 degrees to 22.5 degrees. 4 centuries old, still working. 20 minutes. The material cost $16 per cubic meter. A homesteader built one for under $300 and held 600 degrees overnight. Yet no OL listing exists for any residential sand battery. No building code in 49 states provides a pathway. This is not a story about ancient history. This is a story about a technology so cheap and so effective that modern industry had to pretend it does not exist. So the real question is not whether it works. It is why modern energy systems structurally ignore it. The earliest documented reference point in this investigation appears in Malbork Castle, Poland, 1822. At that time, the castle was already over 500 years old. Researchers studying the site focused on a massive banquet hall measuring approximately 850 square meters, with ceilings rising multiple stories high. Beneath the floor, they discovered a hidden thermal system consisting of granite boulders and engineered air channels connected to an ancient furnace structure. This was not decorative architecture. It was a heat storage mechanism. A controlled experiment was performed. Approximately 0.7 cubic meters of spruce wood was burned over several hours to charge the system. Once combustion stopped, the system was left to operate passively. Within 20 minutes, the temperature of the hall rose from roughly 6°C to 22.5°C. This was a fully passive stone-based thermal system still functioning after centuries. The result was recorded and verified, but no industrial replication followed. It remained historical evidence rather than deployed technology. They coded it out. They cannot code out physics. Subscribe, the next archive opens soon. Now let's get back to the investigation. The same principle appears earlier in Roman engineering through the Hypocaust system, where hot air from furnaces was circulated beneath raised floors and through wall cavities. Stone absorbed thermal energy and released it slowly into interior spaces. Entire Roman bathhouses were heated this way, without direct flame exposure inside living areas. But even this was not the origin of the idea. What if the way we heat our homes today isn't actually new at all? Over 3,000 years ago, in Korea, people were already using something called the Ondol system. A fire burned outside the house, and the heat traveled through stone channels under the floor. Those stones didn't just get warm, they stored the heat, slowly releasing it for 12 to 24 hours. Imagine that. One fire, and your home stays warm all day. By the time of the Joseon dynasty, this wasn't a luxury. It wasn't experimental. It was normal. Everyone used it, and even today, more than 90% of homes in South Korea still use modern versions of this same idea: radiant floor heating. Now shift to China. Over 2,000 years ago, another system appeared, the Kang. It was a heated masonry platform connected to a stove. People cooked, slept, and stayed warm, all using the same structure. One system, multiple uses. Heat stored inside the building itself. And this wasn't ancient history that disappeared. As recently as the early 2000s, around 175 million people in northern China were still using Kang systems. So here's a question. If humans figured out efficient heating thousands of years ago, why did we move away from it? Now jump to Finland in the 1980s. During an energy crisis, engineers Reijo Karppinen and Eija Valtonen developed massive soapstone heaters under the Tuulikivi brand. These heaters weigh several tons, but here's the interesting part. They burn intensely for just 30 to 60 minutes. That's it. After that, they slowly release heat for up to 24 hours. Today, there are over 300,000 of these systems installed around the world. Different place, different time. Same idea. Burn once, store heat, release slowly. This principle hasn't changed for thousands of years. Now modern science steps in. Researchers at the U.S. National Renewable Energy Laboratory studied thermal energy storage using simple materials like silica sand. What they found is surprising. Storing energy as heat in sand costs about $4 to $10 per kilowatt hour. Lithium-ion batteries? Around $300 per kilowatt hour. That's about 30 times more expensive. And when you look at materials, the difference becomes even bigger. Silica sand costs about $16 per cubic meter. Lithium-based systems? Around $39,600 per cubic meter equivalent. That's over 2,500 times more. So why aren't we using this everywhere? Here's another question. What if the limitation isn't technology, but the system around it? Let's go deeper. Sand can be heated above 1200 degrees Celsius for over 500 hours without breaking down, no degradation, no loss of performance. Unlike batteries, it doesn't wear out over time. And here's something even more interesting. When one side of a 1 meter block of sand is heated to about 500 degrees, it can take more than 8 days for that heat to move through. 8 days. That means sand doesn't just store heat, it slows it down. It holds it in place. It becomes a thermal battery. In 2018, two Finnish engineers, Tommi Aronen and Markku Yilman, decided to turn this into reality. They founded Polar Night Energy. Their first system used about 100 tons of sand. It stores around 8 megawatt hours of heat, enough to supply around 100 homes and even a swimming pool. Then they built something bigger. A system using 2,000 tons of crushed soapstone. It stores about 100 megawatt hours of energy and delivers about 1 megawatt of heat. And it reduces carbon emissions by around 160 tons every year by replacing oil heating. No chemical batteries, just stored heat. So again, if it works, why isn't it everywhere? The answer isn't simple, but it's clear. In places like the United States, building systems must follow strict codes. The International Residential Code only recognizes standard heating systems, furnaces, boilers, HVAC units. Anything different must go through a special approval process. Engineering reviews. Third-party testing. Local authority approval. It can cost tens of thousands of dollars, with no guarantee it will even be accepted. And here's the key issue. No residential sand-based heating system currently has official certification. Without that, it's almost impossible to scale. Then comes the financial side. Home appraisals don't value systems they don't recognize. Even if they save money, they might not increase property value. Insurance companies see them as risk. Coverage becomes harder. And then there's the market itself. The US residential heating market is over $12 billion a year, and about 60% of sales happen when systems break. Think about that. The system depends on failure. Repair, replace, repeat. So what happens when a system doesn't fail, doesn't degrade, and barely needs maintenance? But because it works in a way that modern systems are not structured to recognize. Do you think you'd enjoy it? Click the like button and subscribe to our channels for more videos.